Okay, so what we're going to do in this video is solve equations that involve rational expressions. And our method for this is going to be clearing fractions, is what it might have been called previously, but multiplying both sides by the lowest common denominator, least common denominator. So looking at each equation first, rational expressions are there if you have variable expressions or just plain old numbers in the denominator. So I'm going to focus on those. And with this first equation, it looks like we're going to have to multiply by both x and x minus 30 in order to clear the fractions. So notice that this is not multiplying by 1. This is multiplying both sides by the same thing, which we know is valid for any equation to solve. So looking at the left-hand side, the x's would cross out because remember, this is really over 1. So we have 50 times x minus 30. And on the right-hand side, since this is over 1, the x minus 30s would cancel out, and we have 40 times x. Now it looks like a quote-unquote normal equation, one that we have actually solved before. So distribute the 50, and I am going to subtract 50x from both sides to get all the x's to one side. So you have negative 1500 equals negative 10x. And if we divide both sides by negative 10, we have x equals 150. And that truly is the solution. Now, something about rational equations to be careful of is sometimes it is possible that we get one of the values of x that make one of the fractions undefined as a potential solution. So we just have to make sure that whatever we get makes the original equation defined. Okay, we'll explore that as it comes up in our next couple examples. So here is another one. This is just a straight up mathematical example. And the first thing I notice is that the right-hand denominator looks like it can be factored. So let's factor before we try to figure out LCD, just like we did with adding and subtracting. And notice that that is x times x plus 3. So I'm going to rewrite the equation with the factored form on the right, just so it's not so clustered together. So you have 9 over x times x plus 3. And it looks like the LCD is x times x plus 3. So doing that, we have x times x plus 3 times the entire left side, and the entire right side is multiplied by x times x plus 3. Now, whoops, for some reason that one looks like a minus there. There we go. So remember that when you multiply several terms by the same thing, we use the distributive property. So we have x times x plus 3 times 4 over x plus x times x plus 3 times x over x plus 3 equals, now on the right hand side, I'm actually going to take a bit of a shortcut. I know this is over 1, so these cross out and we're left with 9. So remember, whenever we multiply by something that has the same denominator, those terms are going to drop out. So this x cancels out here, this x plus 3 cancels out here, and let's see what we end up with here. We have 4 times x plus 3 plus x times x, which is x squared, equals 9. Okay, so let's see what happens next here. I'm going to go to the right there. So it looks like we have 4x plus 12 plus x squared equals 9. And I'm going to write the left-hand side in descending order so it's easier to read. And then we're going to subtract 9 from both sides. X squared plus 4x plus 3 equals 0. And yes, you could use quadratic formula at this time to solve the quadratic, but this one is actually relatively simple to factor. Factors of 3 that add up to 4 are 1 and 3. And we know that this means that x is equal to negative 1 and negative 3. But now looking back up at the original equation, so I'm going to start writing in red here. As far as the original equation goes, If I look here, oh, I wanted to write that in red. That's okay though. If I look here, this means that I know that x is not able to be equal to 0. And if I look here, that tells you that x cannot be -3. But would you see, we got -3 as one of the potential answers, so we just don't include that one. -3 makes some of the expressions undefined, so it can't be a solution. So our only remaining solution is -1. Okay, so that's solving probably the most complicated one that we'll ever have to solve rational expression. So just a rational equation. So just beware of the values of x that make a denominator equal to 0. Okay, and now for an application. In this course, we talk about average cost. So let's say that we have an average cost function of 40 plus 500 over x. We want to figure out the number of units, which remember was x, when the average cost will be $60 per unit. So basically, we want to solve the equation 60 equals 40 plus 500 over x. And if you want to go ahead and multiply both sides by x first, you can. I notice that I can combine the 60 and the 40 by subtracting 40 from both sides. So I'm going to go ahead and do that first. And writing that out, we have 20 equals 500 over x. I'm going to multiply both sides by x now, so I'm going to switch colors yet again. And now we have 20x equals 500. Divide both sides by 20. It looks like x equals 25 units. So it means when there are 25 units produced, the average cost per unit is $60. Okay, so there's a little bit of an application of rational expressions for you as well, as far as solving equations go. So thanks for taking the time to watch.